Okay, everyone. So something, I don't exactly know what it is, but something's happening with my other camera. So this is on the webcam, but I think I have it framed okay. And I know the sound is probably not as good because it's through the um, computer microphone and not through my other setup, but I'll try to get this fixed before next time. I noticed it like right before my 8 a.m. class, and I had a class the whole time, whatever. Okay, so before we started, someone requested that we go over a couple of problems that were like homework problems. And so I've got them up here on the board, and that's exactly what we're going to do. So we'll go over a couple, and then after that, I'll see if you guys want to go over anything else that's similar to this. And then we'll pick up where we left off, which was something with inequalities, and move on from there. Okay, so this first one says we want to solve the following equation for A. So notice there are 4 total variables, S, A, B, and C, but we want to get the A by itself. Right now we have the S by itself. So let's see what we've got. We have an A term right here, and we have an A term right here. And so the idea is you want to move everything with an A to one side of the equation. I generally think the left, but it doesn't really matter. And everything without an A to the other side of the equation. So that means I'm going to take this guy right here, move it over to the left of the equation. This guy right here, move it over to the left of the equation. And then this S right here, notice there's no A attached to it, so we'll move it over to the right of the equation. So let's see what we get if we do that. So if we add 13AC to both sides, that's what we mean by moving it across. We have to add 13AC, so that's going to give us a 13A times C on the left. And then we'll subtract subtract 8AB. So that's what it would take to move that over to the left. So it's going to be minus 8AB equals, so now we've got this 11BC that was already there. And then we need to subtract this S over, so that was part of the game as well. So we'll do minus S minus S. So it's going to be something like that. So now we have this set up where on the left-hand side, we have everything with an A. Notice there's an A right here in this term, and there's an A right here in that term. And then over here, there are no A's. So that's like your first checkpoint that you want to pass when doing one of these problems where you solve for one of many variables. The next thing that you want to do is use the distributive rule in reverse. So in other words, you want to factor. So you notice that there's A here and there's A here. So that means we can distribute it out of the left-hand side. So I'll put it in front. So we have A times, now this is going to be 13C minus 8B equals 11BC minus S. So I didn't change the right-hand side. The left-hand side did change a little bit, but only by factoring this A out. Now notice if I were to do this back in reverse, if I were to multiply this through, I would get back to this previous step, so I haven't changed anything. But now this is an important place to be because notice the only place that A shows up in the left-hand side now is this term right here. So we have A times something else. It's just that something else is like pretty big, but we can just divide by that. So A times something equals something. Well, we just divide by this block right here. So that's going to give us A equals, so we've got 11BC minus S over this thing right here, 13C minus 8B. And now we've got A solved in terms of everything else. Okay, So the first thing that I'm going to do is expand everything. That's a good first step regardless. I mean, over here it was already expanded, but I would say that if it's not expanded, expanding everything is like a good first step. So that means we're going to distribute this through to both terms. So we're not changing the left-hand side. That's going to leave us with a k on the left-hand side. Then distributed through, we have u times s over 3, and then plus 8 times u times c over 3. So our goal is to get s by itself, and we can do this next step kind of whenever we want, but I would say maybe now is a good time to get rid of the fractions. And so we can do that by thinking about this as k over 1, then multiplying the whole thing by 3. That's going to cancel out all the fractions. And now we can start going towards our goal a little bit more strongly, and our goal is to solve for s. So we want to get s by itself. Notice the only place that s shows up is in this term. So we want to isolate all the stuff with s. So maybe I'm going to do that in this case by subtracting 8uc from both sides. So let's see what that gives us. That gives us the left-hand side will be 3k minus 8uc equals us. Now, generally, it's a little bit more standard to have the thing that you're trying to solve for, in this case, s, on the left-hand side of the equation instead of the right-hand side of the equation. But, you know, we can just flip that, right? So this is going to be the same thing as u times s equals 3k minus u, 8uc. And now, again, we want to get s by itself, and so we need to divide this by u, which means we need to divide this by u as well. So that's going to leave us with s equals, so we have 3k minus 8uc over u. And then I would say that's maybe the best way to write this down, but you could rewrite it as 3k over u minus 8c. That would be another way to write it. Notice we've got 3k over u, and then the u cancels that one to just down to 8 times c. Okay, so that's what I have for this first one. So maybe my favorite thing to do for things like this is to get rid of the fractions by multiplying by whatever it takes to cancel out those denominators. In this case, it'll be 5 times 6 because that's like the least common multiple of 5 and 6. Now we're viewing this minus 5 as 5 over 1. So now if we take this whole equation and we multiply it by 5 times 6, which is 30, we can have some nice simplification here. So keep in mind that we have to distribute this 30 onto all of these terms. And being in the numerator of a big fraction is the same thing as being inside parentheses like that. Then you're going to have to distribute it here and here. Okay, so let's see what that gives us. So 30 times x over 5. So let's just maybe write all the steps. So we have 30x over 5 equals minus 5 times 30. So that's what we get from that one. And then plus 30 times x plus 28 over 5. Sorry, over 6. So we've got something like that. And now we can start simplifying. So we know that 5 goes into 36 times, and 6 goes into 35 times. Then we also know that 5 times 30 is 150, and then this has got to be negative also. So that gives us a little bit of simplification. So we have 6x on the left-hand side, and then minus 150 plus 5 times the quantity x plus 28 on the right-hand side. Good. Then next, well, we've got to distribute this 5 onto both of these terms. So onto the x term and onto the 28 term. So let's see what that gives us. So we're going to have 6x remains on the left, negative 150 plus 5x. And then let's see, 5 times 28, so that's going to be 140. Yeah, because 5 times 20 is 100 plus 5 times 8, so yeah, that's 140. So we get something like that. Good. Now we can go ahead and combine things. So maybe move this 5x over to this side of the equation by subtracting. That's going to leave us with an x on the left-hand side. And then on the right-hand side, we're going to have minus 150 plus 140, so that's minus 10. So we should have minus 10 in the end. Okay, so we have two things that we can do here. We can multiply everything by 2 to get rid of the fractions. And I would say that's maybe like a good first strategy, although it's not as required in this case because the fractions are isolated, but let's go ahead and do that. So we can take this entire inequality and multiply it by 2. Now let's keep in mind that all of this stuff in the middle is going to be grouped so that when we make this distribution of the 2 through to all of these parts, we have to take that into account. So let's see, 2 times negative 1/2, so that's going to give you negative 1. And then that's going to be less than or equal to 2 times 5x minus 3. And I'm just going to leave that in parentheses for now. And then 2 times half is 1. Now I want to go ahead and simplify that, the interior of that inequality. So I'll just rewrite the first and the last bit of it. And then now this will be 10x minus 6, just from distributing the 2 onto the 5 and onto the 3. Now I can start getting the x by itself. So I can add 6 to both sides. So let's see, negative 1 plus 6 is going to be positive 5, less than or equal to 10x, less than or equal to 7. Now we can like go ahead and divide by 10. So divide by 10, divide by 10, divide by 10. So 5 over 10 is a half. Then we get x by itself. And then 7 over 10, well, that's just 7 over 10. You can't really make that any simpler. So that is the solution like as an inequality at the end. But if you wanted to write it in interval notation, maybe we would want to go through the number line first. So you put a half on this side, 7/10 on this side, making sure we're going from least to greatest. And then notice that we include both of those. So I'll put a closed circle here and a closed circle here and shade everything in between. So that's like a picture of our solution set. But then as an interval, that is going to be bracket, half, 7/10 bracket. And that means we're going to include all of the numbers between a half and 7 over 10, including a half and 7 over 10. Okay, so maybe before we move on, let's just kind of sketch what an alternative first step would be. So I'm just going to rewrite this. Minus half is less than or equal to 5x minus 3, which is less than or equal to half. So an alternative first step would be just to go ahead and add 3 to all parts of this inequality immediately. And here we're going to have 3 minus 1/2 is less than or equal to 5x, which is less than or equal to 3 plus 1/2. But then you need to find a common denominator and simplify those. So I would maybe write 3 over here as 6 over 2. And over here, well, also is 6 over 2. And so 6 over 2 minus 1 over 2 is 5 over 2. So we've got 5 over 2 less than or equal to 5x less than or equal to, well, that's going to be 7 over 2 because it's 6 over 2 plus 1 over 2. But now if we arrive at this point, notice we divide by 10 and we divide by 5 and we end up at the same thing that we ended up there. So it's really up to you which order you want to do it in. As long as you're careful with all of the bookkeeping, it should be fine. Let's go ahead and go over the last one on this. I went around to the groups and everyone seemed to be doing pretty well. I got to most of the groups. So let's go ahead and go over this last one, and then we'll move on to some different types of compound inequalities. So this last one had -4 is less than or equal to all of this stuff. So 5 minus x over 3 minus 2 is less than 7. So the first thing that I want to notice is that maybe a good thing to do would be to add 2 to all parts of this inequality so that we can maybe not isolate the variable just yet, but isolate this stuff that the variable is wrapped up in. So notice the variable is wrapped up in like this 5 minus x over 3 stuff, and it's easier to isolate that than it is the variable just initially. So we can add 2 to all sides of this inequality. That's going to leave us with a -2 over here. And then we have 5 minus x over 3 in the middle. And then we have a 9 over here. Now we can clear the fractions, sort of like our favorite thing to do. So multiply the whole thing by 3, keeping in mind that we're thinking about this as like 2 over 1 and 9 over 1. So distributing this 3 through onto all of these. So on the extreme left, we'll have -6 less than or equal to 5 minus x. So the 3 in the numerator cancels the 3 in the denominator, and then less than 27. Now we're almost there, so we can like maybe subtract 5 from all parts of this inequality. And that's going to leave us with -11 is less than or equal to -x, which is less than 22. But we don't have x isolated, we have -x isolated. So we need to change the sign. And so we can change the sign here by either multiplying or dividing by -1. It's like kind of the same thing. So if we multiply and or divide by -1, that's going to turn this -11 into an 11. This -x will become an x, and this will become 22. But that's going to require us to change the direction of all of these. So this is going to turn into a greater than or equal to, and this is going to turn into a greater than. So we end up with something like that. And notice if we had not changed them, then it wouldn't have made any sense, because we would have had an 11 over here is less than a -22, but 11 is not less than -22, it's bigger than. So we had to change them because of the rule and for this to make sense in the first place. So now what I would like to do is rewrite this. So working from left to right, we go from smallest to biggest. So that means I would start over here with -22 is less than x, which is less than or equal to 11. So I just like mirrored that, if you will. But now we can maybe make an interval with that. Now we can maybe make an interval. Someone learned my secret. We can make an interval with that, and then, or sorry, maybe a graph with that, and then an interval. So let's see. We'll put -22 on the graph, 11 on the graph. I can't really do that because I have, well, you guys can't see this, but I have these microphones right here, and I hit them. It's a unfortunate upgrade of the studio, is that it disallowed me from being able to do backflips anymore because I'd hit these microphones. Okay, anyway, we can put open circle, closed circle, shade it. So that's our graph. And then in interval notation, it's going to be not -22 to 11. We do not include 22, but we do include 11. Good. So I think, I mean, this is a good one to look at. Of all of those, it has kind of the most going on, especially this important part at the end where we had to change the order because of the multiplication by a minus sign. All right, so we got like 15 minutes. So what I want to do in the last 15 minutes is look at some more compound inequalities. ones that you have to use slightly different techniques than we've used so far. Yeah, and then after that, we're going to move on to solving equations and inequalities with absolute values. I'm not sure. We might be able to just like dip our toes into that, but we won't be able to get very far into that today. They may look very, very similar to the ones that we've just been working with. And, you know, why do we need to look at these separately, and why will they not work with the techniques that we've already explored? But we'll see why. So maybe we could put this as a heading as like more compound inequalities or something. Okay, so let's say we have 2t minus 1 less than or equal to 4 minus t. Now, if I stop there, we would totally be able to solve that. There's nothing complicated going on. But if I were to go over here and put 6t plus 1, now these are the type of compound inequalities that we want to work with. Notice that what's going on is that we've got a t in all parts of the compound inequality. And remember that our goal is to get a number on one side, the variable in the middle, and a number on the other side. But with this setup where we've got a variable in each part, that is not possible without breaking this apart into two different questions. And so that's exactly what we're going to do. We're going to think about this as two different problems. One, which is given by this 2t minus 1 is less than or equal to 4 minus t. And the other, which is given by 4 minus t, is less than 6t plus 1. And both of those have to be true, so we like put the conjunction and between them. Okay, good. So let's see. We're going to break this into two. And so, well, let's maybe reiterate real quick how you know that you have to do this. And I would say you can always do this, but you know that you have to do it if you have the variable in multiple places of a compound inequality. So by a compound inequality, I mean a three-part inequality. So if you've got a three-part inequality and we've got a variable in more than one part, then you have to break it into two pieces. Okay, so let's see. Let's do this yellow one first. So that's going to be 2t minus 1 is less than or equal to 4 minus t. And then we'll do this red one also. 4 minus t is less than 6t plus 1. So we have to investigate each of those inequalities separately. And then after we've fully investigated each of these inequalities separately, we can like synthesize their solutions. Okay, but when we look at them separately, we just do the technique that we've just done in the, the last day or two or whatever. So here I'm going to go ahead and add 1 to both sides of this and add t to both sides of this in order to like get the t by itself. So that's going to give us 3t on the left-hand side and then a 5 on the right-hand side. So that tells me that t is less than or equal to 5 over 3. Okay, so we've reduced this yellow condition to t being less than or equal to 5 over 3. Now let's do the same kind of thing over here. So we'll add t to both sides and then subtract 1 from both sides. So let's see what we get. That's going to leave us with a 3 on the left and then a 7t on the right. But let's see, that means that 3 over 7 is less than t, which means t is greater than 3 over 7. So maybe I'll box this in red because that's equivalent to what I have up there underlined in red. And now both of these have to be true at the same time, so I'll put an and between them. Okay, so let's see what we have. We have t must be bigger than 3 over 7 and less than or equal to 5 over 3. But now we can go ahead and put that together. That is equivalent to the compound inequality that 3/7 is less than t, so that's this one right here, which is less than or equal to 5 over 3. So that's this one right here. But now we can go ahead and put this into interval notation like we had with the others. So that's going to be 3 over 7 on the left, 5 over 3 on the right. We include the right-hand endpoint, so we put brackets there. Okay. So what we did is we added the step at the beginning and the step at the end. So the step at the beginning is this breaking it into two parallel questions. And the step at the end is like putting these two conditions back into this compound inequality right here. Like that. Okay. Okay, so if we look at this, it's a compound inequality. By that, I mean there are 3 parts to the inequality, 1, 2, 3. And another thing that we can notice is that there are x's in all of the parts of the inequality. And the fact that there's x's in all of the parts of the inequality really points towards the need to break this into 2 separate inequalities that are joined with the and. So let's go ahead and do that. So we'll break it into this yellow one and this red one. So the yellow one will be 3x plus 1 is less than or equal to 2x. And then this red one will be 2x is less than or equal to x minus 7. And like I said, we've got this and statement between them. Now we work on these separately and then fuse their information back together at the end. So maybe I'll go ahead and subtract 3x from both sides. So that's going to leave us with 1 is less than or equal to negative x. But now we don't want negative x, we want positive x. So we'll multiply this by negative 1. That's going to give us negative 1 is bigger than or equal to x. So we're left with something like that. But now let's go ahead and maybe write that as x is less than or equal to negative 1. Just to put it in increasing order. Or put the x over on the left-hand side, I should say. Now let's go ahead and do the same thing over here. So let's subtract x from both sides. So that's just going to leave us with x is less than or equal to negative 7. Okay. So, well, that's the end of that. So let's see what we've got. We have this and statement that x is less than or equal to negative 1 and it's less than or equal to negative 7. So I'm going to go ahead and go through the graph for this so that we can get a feel for exactly what we need. So notice that the 2 important points on the graph are negative 1 and negative 7. So let's maybe graph this one in green. So in green, that would be like everything to the left of negative 1. Then let's maybe graph this one in blue. So that's going to be everything to the left of negative 7. But we've got this and statement, which means both of these have to be satisfied. But if both have to be satisfied, well, this one is stricter than this one, right? So notice if x is less than or equal to negative 7, then it is forced to be less than or equal to negative 1. So that means our final answer will just be this right here. It's like taking the intersection of these two sets. So in the very first example, these guys were like pointing in opposite directions. So since they were pointing in opposite directions, you got this finite interval. But here they're pointing in the same direction. So you have to take whichever one is more restrictive. And in this case, x being less than -7 is going to be more restrictive. So that means our final answer will be minus infinity to -7. So parentheses on the minus infinity because that always gets a parentheses, and then a bracket on the -7 because that gets a bracket because it includes that -7. Okay, so we've got like 3.5 minutes left. I want to do one more real quick, and then we'll be done. So let's see. So we've done a bunch with and conjunctions in between. I want to do one with an or conjunction. So let's say 2 minus 3x is less than -5, or 2 minus 3x is bigger than or equal to -3. So we're going to do the same kind of thing. I'm actually going to change this to 2 plus 3x for now. 2 plus 3x. Okay. So we're going to actually do this. Sorry, this should be +3. So we're going to do the same kind of thing, work these in parallel, and then fuse the information together at the end. So over here, we need to subtract 2 from both sides. Over here, we'll subtract 2 from both sides. So let's see, that's going to give us 3x is less than -7, or 3x is bigger than or equal to 1. So we've got 3 minus 2 is 1. Now we can divide both sides by 3. So here we have x is less than -7/3, or x is bigger than or equal to 1/3. So this would be a description of our solution, with this like kind of sentence structure with the or conjunction between them. Now let's go ahead and graph this. So we want to graph these two parts. So let's see, if x is less than -7/3, so we need to put -7/3 on the number line. We do not include -7/3 because we've got that less than, and then everything to the left. And then we'll put 1/3 on the number line. So we do include 1/3 because we've got a greater than or equal to, and then everything to the right. Great. But now since we have an or, we need this stuff or this stuff. But if you recall from the first couple days of class, we can do that using a union of intervals. So this left-hand part is -infinity to -7/3. This right-hand part is 1/3 up to infinity. We include the 1/3 in this case, and the way to put them together is with this union. Okay. But let's just say there was an and here instead of an or, then there would be no solution because there are no numbers that are less than -7/3 and bigger than 1/3, but the or, makes it possible in this case. So this would be like your final answer. And interval notation would be this stuff right here. It is a union of these two intervals.